Good morning, sir. I am Samisha Tandare. I am going to present designing synchronous buck converter using PWM and logic control, presented by Ankita Raktate and Samisha Tandare, guided by Vijay Kumar sir. Index, introduction, overview, methodology, simulation, block diagram, simulation result, advantages, disadvantages, application, conclusion, and reference.
Introduction: Synchronous buck converter DC to DC step-down converter uses the two mop set high side and low side for higher efficiency. PWM controlled converter switching frequency and duty cycle for pulse width modulation. And logic control prevent the both switches from turning on together. Ensure the high efficiency, low heat loss and stable voltage. Common in the laptop, solar system, electrical vehicles and microcontrollers. Second one is the overview. A synchronous buck converter is a DC to DC converter that the step down the voltage and efficiently. It is used to two MOSFET, one high side and one low side. It is used for the MOSFET inside the diode to reduce the losses. The converter operates based on the pulse width modulation technique. The pulse width modulation control adjusts the duty cycle to regulate the output voltage. The logic control the circuit ensures the correct switching of both mobs set to avoid the short circuit. Methodology: problem identification. Need for efficient step-down DC to DC converter with minimal power loss. System design. Plan the converter circuit using two MOSFET high side and low side synchronous operation. PWM signal generation. Use a microcontroller or PWM IC integrated circuit to generate the variable duty cycle pulse at the control output voltage. Logic control circuit. Design the logic to ensure the proper timing and dead time between the switching of the both MOSFET to prevent short circuit. Component selection. Choose the MOSFET indicator, capacitor, and resistor will decide the voltage, current, and efficiency rating. Simulation and testing. Simulated the circuit software like MATLAB, ELT to verify the performance and make the necessary tuning.
Simulation block diagram, uh, current sensor, DC source, N channel MOSFET, N channel MOSFET 2, RL load, voltage sensor, R load, cyclic load, give supplies 200, and DC we use 30 volt input supply to give 15 output supply.
The simulation result. The waveform is the DC to DC converter is the step down. It is the output showing. Advantage: high efficiency, reduce the power loss due to the use the MOSFET instead of the diode. Better performance, provide the faster transient response and stable output. Compact design, the smaller size due to the high switching frequency, improve the control. PWM allows the precise voltage regulation, reduce the heat generation, less energy wasted as heat improvements reliability. Disadvantage: complex control circuit requires the logic control and daytime management. Higher cost, more the component like gate drivers increase cost. Risks of shoot through. If the timing fails, both MOSFET may conduct simultaneously. Electromagnetic interference means the high efficiency switching may cause noise. Difficult design and debugging needs the careful turning and simulation.
Application. First application is microcontroller and processor. Power supply means provide stable low voltage DC for CPUs and MCUs. Second application, better power device means improve battery life by increasing power conversion efficiency. Application third, laptop and mobile charges means used in efficient step down power section. Automotive electronics means power sensor control unit and infotainment system. DC motor device means used to control speed by adjusting output voltage. And conclusion, desynchronous buck converter means DC to DC converter and two types of higher and lower by replacing their a traditional diode with a low side MOSFET. It is significant reduce power losses and improve overall performance. The combination of PWM control and logic-based synchronization ensures stable output, better voltage regulation, and higher efficiency. This design is widely used in modern power electronic application, especially where compact size, precious, and energy efficiency are important. These are references. Thank you.